Alright, geometry students, let's get it on. First one. Tell which triangles you could show are congruent in order to prove the statement, which postulate theory would you use. In this one, I've got angle, angle, side. Even though it's a 90, the fact that it's 90 not important. This is going to be angle, angle, side, congruent postulate. And which ones would I use? It would be HGL, and that would end up being congruent to JKM. Once I got that, M and H and L, angle H and angle L, angle H and angle J rather, those would be CPCTC. On this one, you've got this triangle up here, angle, angle, side. You've got this triangle right here, angle, angle, side. That one's a lot easier. There's nothing really to confuse that. Angle, angle, side, congruent postulate. And that's going to be triangle, I'm going to start up here in the corner, UPQ. That's going to be congruent to triangle SVP. Looking at this next one, I've got angle A, congruent to angle D. That's what I want. Alternate interior angles is what we're going to use to get our final piece. That's going to make it ASA. And I'll go congruent postulate on that. I will go triangle EFD. And that's going to mean I start up here at BBCA. Moving right along, prove RZ, look at RZ, is congruent to YU. Now, a little weird. What I'd like to do is use a quadrilateral rule that, interior angles of a quadrilateral equal 180, but what we're going to use instead, we're going to do our angle addition postulate to, well, we might use congruent supplement there, and that's, let's do that. So the first thing we're going to do is say that, and once we get that, we're going to CPCTC the side that we want, because we have angle, or side, angle, angle. So the first thing I'm going to do is say that, we'll call this angle 1, angle 2, angle 3, and angle 4. I'm going to make 1 and 2 supplementary, 3 and 4 supplementary. Since 1 and 4 are congruent by the congruent supplement theorem, 2 and 3 must also be congruent. Once I have that, I've got angle, angle, and then side. And I'll CPCTC, RZ, and YU. Here we go. So I'm going to say that angle 1 is supplementary to angle 2. That's the definition of linear pair. Angle 3 is also supplementary to angle 4. I'm going to call that out. We also know that angle 1 is congruent to angle 4. That's a given. That's going to make angle 2 congruent to angle 3 by the congruent supplement theorem. If you have two angles that are congruent or that are supplement to congruent angles, those two angles have to be congruent as well. So now I have my corner angle. I'm going to call out angle R. It's congruent to angle U. Right angles are congruent. Well, we'll just call that given. They are marked with the same angle measure. And they're right angles. Continuing on for that one, we have our sides. And I'm going to say SR is congruent to TU. That's also given. It's going to allow me to claim my triangles. Triangle SRZ is congruent to triangle TUY, and that's going to be angle, angle, side, like we talked about. And then I'm going to CPCTC, my last step. So the step that we wanted, RZ, is going to be congruent to YU, and that's going to be CPCTC. Once we get the triangles proved, we can rip off the part that we want. Looking at this next one, I looked at it for a while and was like, oh, that's super easy. So we've got angle G congruent to angle I. That's going to be given. I'm going to grab this vertical angle right here. We'll call this 1 and 2. Angle 1 is congruent to angle 2. Why? Vertical angles are congruent. Some of you guys love other things. Don't love other things. Love this. Vertical angles congruent. And then I've got FG and JI given to me. So FG is congruent to JI. And that's going to be given. Gracious. Anyway, and then I've got those two triangles. I'm done. We're going to say FGH is congruent to JIH. That's going to be angle, angle, side. And then finally, taking CPCTC off the side that I want. FH is congruent to JH CPCTC. Done. That one was fun. All right, going to this next one. This next one, a little bit dangerous. Lots of different ways to do it. What I like doing, because I want to get these two triangles congruent, this one and this one. What I'm going to do is grab this side, this angle, and then this side right here. It's going to make my big triangles congruent. Once I get my big triangles, these little triangles, I can CPCTC off this side, I can CPCTC this angle, and they share this side. And that'll allow me to call those two little triangles congruent, at which point I can CPCTC off angle 1 and angle 2. Here we go. The first thing I need is this one. I'm going to call it out, just to call it out. We're going to say BD is perpendicular to AC, and that's given. That's going to make angle, and I'll call this 3 and 4. It's going to make angle 3 and angle 4 right angles. Definition of perpendicular. And then I'm going to say angle 3 is congruent to angle 4. Right angles are congruent. Just getting a little fancy there to make sure I don't miss anything. From there, BD is shared on my big triangles. Reflexive. AD is going to be congruent to DC. It's going to be given. And then I've got my first set of triangles. My big triangles are now congruent. Triangle ADB is congruent to triangle CDB. It's going to be side, angle, side. From there, I'm going to start ripping off pieces, and I'm going to transfer it this time to a piece of paper. From there, I'm going to start ripping off pieces that I want. We'll call this angle 5 and angle 6. Angle 5 is congruent to angle 6. Get a line going on. That's going to be CPCTC. We're going to say that BA is congruent to BC, also CPCTC. And my last piece that I want, BE, is shared between my two triangles up top. And that's going to be reflexive. And now I can grab this little triangle and this little triangle and call them out as congruent. So I'm going to go triangle ABE, and it's going to be congruent to triangle CBE. And that's going to be side, angle, side. From there, angle 1 and angle 2 are a simple CPCTC away from victory. Boom! We're going to cut the video here, continue on.